So we didn't get a lot of time for this in the lectures or in the tutorials, and I tend to give other things priority because it's not something that's assessed. But factograms are pretty cool and also pretty useful for enumerating all of the factors of a given number. So they rely on factor trees first. So the first step is always to do a factor tree. And then we want to identify the prime factors. Oh, that says prime. Identify the prime factors, and then as well as what the prime factors are, how many of each, how many repetitions we'll say. And then the last thing we want to do is, make the factogram. Okay. So let's go through each of these steps. Now, we want to start with a number. So let's take a reasonably simple number to start with. Let's just start with 12. Okay. So 12, and then we want to do a factor tree for this number. So remember, with factor trees, we separate it down. So 12 is the same as, say, 3 times 4, and then the 4 becomes 2 times 2. And so our prime factorization is 2 times 2 times 3, or 2 squared times 3. So this is our prime factorization. Now, to put this into a factogram, now notice as well, okay, before I go into making the factogram, notice that with this factor tree we get the 12, 3, 4, but not all of the factors of 12 appear. So for instance, we don't get the 6, and we don't get the 1. Now you can imagine with much larger numbers, obviously we're going to miss many, many more factors, not just a couple. So our prime factors in this case, so we're up to this step now, our prime factors in this case are 2, and it's repeated twice, and 3, and it's only repeated once. Now basically, so here we have 2 factors, and so this means that we're going to have a 2-dimensional factogram. Further to this, we have, so 2 is a repeated factor, so therefore it's going to have 2 steps for 2, but then for 3, just 1 step for 3. Now I'll say what I mean by that now. So we have to, we're creating 2 dimensions, so I hope you know, like, if you've just got 1 dimension, that's just length and it's just basically 1 direction, but then if we have 2 dimensions, then we have length and width basically, so something like this. So that's our 2 dimensions in this case, and we'll go up to 3 dimensions for some numbers. So what I do is I basically allocate a dimension to to each prime factor. So I'm going to make the vertical dimension mean times 2, and I'm going to make the horizontal dimension mean times 3. Okay, so this is how I start. So I've identified I've done the factor tree, I've identified the prime factors. Now the extra thing that I have to take into account here is that we take 2 steps for 2. So when building my factogram, I'm going to go start here. Okay, I'm going to go 2 steps upwards, so 1, 2. Now the reason why I go 2 steps upwards is because 2 was a repeated factor twice. So I can write in times 2 here. And then in the other direction, I only go 1 step because 3 was only there once. So I go here. This means times 3. And so now we fill out the lattice completely. So it's going to be a nice grid. And so I go 1 across each time for the 3 and 2 up each time for the 2. And then I can fill in the numbers. So I want to start with a 1. So let's maybe go color these in, we can make it prettier. So these are all of the placeholders for all of the factors I'm going to have. So already I can identify that I'm going to have 6 factors. So I'm going to put in a 1 here. Each time I go upwards in this direction, I multiply by 2. So 1 times 2 is 2. 2 times 2 is 4. In the other direction, each time I go across in this direction, I multiply by 3. So 1 times 3 is 3. 2 times 3, goes times 3 here, is going to be 6. And 4 times 3 is my 12. So this is what the factogram looks like for 12. It has all of the factors there, 1, 3, 2, 6, 4, and 12. And we can even, with each of the factors, we can identify kind of what it's composed of. So the number 6, for instance, is to get to it, I go times 2 and times 3. And so the prime factorization of 6 is 2 times 3. Okay, so let's do another few examples and we can get kind of a feel of how these factograms work. Okay, so another example. Maybe let's do 100. Okay, so 100 is a pretty nice one because 100, when we break it down, easiest way I hope to break it down, I think, is just doing 10 times 10, and then break those 10s down as well, and we'll get 2 and 5, 2 and 5. So this is all about prime numbers. And so the factorization for 100 is 2 times 2 times 5 times 5, or 2 squared times 5 squared. And so again, identifying those prime factors, I'm going to have 2 steps in the 2 dimension, and then 2 steps in the 5 dimension this time. So again, start out, I'm going to make maybe, I'll go 2's upwards again. So put in my starting point here. I'm going to go up twice in the 2 dimension, and then across twice. So just make sure I know that this is times 2, and then across twice in the 5 dimension. Now I have to fill in the whole grid. Okay, so it's always going to be a rectangular grid with everything filled in. And now I can fill in my numbers. So we're going to start down here with 1, and just to keep here, so it's times 5 times 5. So 1 multiplied by 2 is 2, multiplied, that was going that way, and then multiplied by 2 again will give me 4. Now every time I go right, I multiply by 5. So 1 times 5 is 5 here, times 5 again gives me 25. 2 times 5 gives me 10, times 5 again gives me 50. 4 times 5 gives me 20, and times 5 gives me 100. Now with this one, it's a little bit easier to see a few of the different parts. So I could have each of these times, I could have multiplied by 2 up to here. So 5 times 2 is 10, times 2 here gives me 20, 25 times 2 gives me 50, times 2 gives me 100. So all works like that. And so this enumerates all of my factors of 100. So all of my factors are 100, include the 1, 2, 5, 4, 10, 20, 25, 50, 100. Now, again, each of these factors as well can be seen, how we get to it. So the number 20, for instance, is 2 times 2 times 5. So 2 times 2 times 5 gives me 20. To get to the number 10, I can either go 5 times 2 or 2 times 5. 2 times 5 equals 10, etc. So this gives us all of the factors of 100, and we can It's a nice systematic way of finding them all. Now let's see what happens in an example where we only have one prime factor. So let's look at the number 16. We don't need to go too high. So 16, when we break 16 down, we'll go to 2 and 8, and then break the 8 down into 2 times 4, and then break the 4 down into 2 times 2. And so we get 16 is just 2 times 2 times 2 times 2, or 2 to the power of 4. So in this case, we only have one factor, prime factor. But it's repeated 4 times. So if you remember some of what I was saying before, we want to work out how many prime factors there are and how many repetitions, and the number of times it's repeated corresponds with the length. So in this case, the prime factor 16, we're only going to be one-dimensional, so I'm just going to go across in this direction, and each time I go across is going to be times 2, but I go 4 steps, so I'm going to have 1 times 1 step, 2 steps, 3 steps, 4 steps. And filling in each of my numbers here, starting with 1 times 2 gives me 2, times 2 gives me 4, times 2 gives me 8, times 2 gives me 16. So I arrive at that 16 again, and this is all of the factors that come from 16. So just 1, 2, 4, 8, and 16. We don't get any extra ones. So whenever we just have a single prime factor, we get just a single length here. We don't need to go in multiple directions. So another example of one that would look like that is, say, for 25. We'd just go 1, 5, 25. And so this is 25 equals 5 times 5. Now, the last type we'll do is we'll get into 3-dimensional ones. So 3 dimensions is when we end up having 3 prime factors. So I think it's actually in the exam notes, but I'll do this example anyway because it's a nice one. So the number 60. So if we do 60 and break it down, let's do 6 times 10 first, and then break 6 down into 2 times 3, break the 10 down into 2 times 5. And so 60 has 3 prime factors, 2 times 2 times 3 times 5. So for representing this one, and I think it's at the 3-dimensional ones that people start getting a little bit afraid of factorgrams, because now we have, sorry, I'll just write this here. Now, because we have 3 factors, we actually need to represent it in 3 dimensions. So we'll have 1 dimension going up. Let's make that the times 5 option. 1 dimension going this way, which make that the times 3 option. But then we're going to have like the depth. I don't want to do 2 as depth actually, so I'll do times 2 in this direction, and then times 3 will be the depth one. So we have to use our 3-dimensional kind of understanding for these ones. Okay, so again, because I've got 2, it's going to be 2 steps in this dimension, but then just 1 step in the 3-dimension and 1 step in the 5-dimension. So let's start with my starting point. I'm going to be going 1 upwards. I'm going to be going 2 acrossways. Okay. And then I'm going to be going in this direction. I'm going to be going just 1 step. Okay, so we have to be able to continue this a little bit as well. So continuing, so going across in the 2-dimension from here, 1, 2. Each time we're going to be going across that way. And then when we go upwards, so upwards from here, upwards once from here, and then in this dimension again. So just filling out a 3D prism type shape. Might be easier sometimes if we draw it properly beforehand and then fill in our things. But so this is what we're going to be filling in. So it's a little bit confusing, a little bit hard to see. Maybe I'll just shade the bottom so that we can say that's the base, and we can kind of identify that as the base. Maybe that will make it easier. Okay, so let's fill in all of our numbers for this one. So again, yeah, I'll just use, I want to use colors. Yeah, let's do this. Okay. Actually, and I might even do, oh no, we'll do that. Okay, so let's start with 1. Now remember, in the 2 dimension, we're going across, multiplying by 2 each time. So 1 times 2 is 2, times 2, again, is going to be 4. Whenever I go upwards, I'm multiplying by 5. So 1 times 5 is 5. 2 times 5, so going up this way, gives me 10. And 4 times 5 gives me 20. So this, you can see on that side there, that would be the factogram for 20. And then when I go depth-wise, I'm always multiplying by 3. So 4 times 3 is 12. So I don't have to do this all in order. I can do it, however I want. So 4 times 3 is 12. 2 times 3 is 6. 1 times 3 is 12. 6. 1 times 3 is 3. And then when I go upwards, when I go up here, I'm multiplying by 5. So 3 times 5 is 15. 6 times 5, if I go that way, is 30. Or if I went from the 10, it'd be 10 times 3. So either way, we should get 30 here. And lastly, when I go 20, let's do 20 this way. So remember that dimension is times 3, I get 60. Okay, so this is our final factogram, and I guess the important thing again is to look at it and recognize that all of the factors are represented. So 1, 2, 3, 4, 5, 6, and then 10, 12, 15, 20, 30, and 60. So we get all of the factors of 60, and we don't have to, they wouldn't appear, or they didn't appear in the factor tree, of course. So we don't get them all that way. And it kind of means we're able to enumerate them without necessarily having to check or do divisibility tests or anything like that. Because usually to find all the factors of 60, you kind of say, does 2 go in, does 3 go in, does 4 go in, does 5, etc. So it kind of enumerates all that. One other thing to notice, so remember, in order to work out how many factors there are, we know that there's going to be, because we go 2 steps in the 2 dimension, there's 3 objects. Because we go 1 step in the other dimension, it's kind of 2. So we get like a 3 times 2 times 2, corresponding with 2 steps, 1 step for the 3s, and 1 step for the 5. So we get 12 factors. We could, similarly, if I have a number, so let's say I have the number and I don't even know what number it is, so say I had 3 times 3 times 5 times 5 times 7, so whatever this number is, I know that I would have 2 steps for the factogram here, 2 steps for the factogram here, and 1 step here, and that would correspond with the vertices on the shape would be 3 times 3 times 2, and so there would be 18 factors in total for that number. So that's another advantage of being able to do this. We can actually, once we have the prime factorization, we can very quickly calculate exactly how many factors that particular number has. Okay, so I do encourage you to, have a play around with these types of things. Even for smaller numbers, so for instance, if we have 20, it's 4 times 5, which is 2 times 2, and so for even the number 20, Actually, did I start with that one? That would be just, no, I started with 12. So for the number 20, we can quickly kind of get it as it's going to be 2 steps. So 1, 2, 4, and then going upwards is 5, 10, 20, and we kind of get our factogram here as well. So for some numbers, quite simple. For a number like 6, which is 2 times 3, it's just 1 step in each direction, so it will be kind of like this, etc. It's worth having a play around with them, getting an idea of everything you can do with them. Okay, I know 20 minutes is quite a long video, but thank you for watching it if you made it all the way through to this. Even though this won't necessarily, or isn't tested on the exam, this can still be useful for you when you're out teaching as a fun kind of exercise. I think it's fun. I hope you think it's fun. Okay, cheers.